Hey everyone, welcome back to Chemistry CC for you. So today we are going to do the part 2 of MG University MSc Chemistry questions. So I have a few things to say before we begin. So we are having so many videos under progress. First of all, we'll be doing the part 2 of Know Your Courses. Then we'll be doing a video on how to apply for various universities. That is for the MSc Chemistry. Then thirdly, we are doing a video on jobs in chemistry where we'll be dealing with each level of your studies, like BSc, after BSc Chemistry, what are the jobs you are available? What MSc Chemistry, what are the various options available for you? After PhD, what are the options available for you? We'll be in detail. We'll be discussing those. Then apart from that, I got request for Kerala University MSc Chemistry questions. I'm trying to make that one as well. Then also JNU. I don't know the examination date. If you could, whenever you are requesting for the videos, it would be really helpful if you're giving the dates of the examination, because in that way I can prioritize the videos, like which one I should post first. So please give the details of the examination, like when it is going to be held. And if any of you have any question papers with you, it would be really helpful. Please go to the about page of our channel. You can find our email ID there, and also we are beginning a Telegram channel as well as an Instagram page. You could message us there as well. So these are the things I have to make in the announcement. So let's begin. The first question today. Gadolinium belongs to 4F series. Its atomic number is 64. Which of the following is correct electronic configuration of gadolinium? So we know that in F series you have F orbital. Also there will be partially filled d orbital as well as s orbital will be also present. Here the gadolinium has an atomic number of 64. So we are writing the electronic configuration in terms of xenon, which has an atomic number of 54. So first of all, Xe has an atomic number of 54, and you're supposed to write the rest of the 10 electrons here. And you have to check each of the options, and we know that half-filled configuration is more stable. In an F orbital, the total number of electrons that can be filled is 14. So in any of the option, if you see F7, that itself would be the correct answer. So our answer is option A, xenon 4F7 5D1 6S2 will be the correct answer, because the half-wave configuration is more stable. So that is the first question. Now the second question, the complexes CuNH36, CrCN6 and CrNH36, CuCN6 are the examples of which type of isomerism. So from the question itself, it is very clear that in both the complexes, the ligands are being exchanged in there. So the complexes CuNH36 and both these complexes are examples of coordination isomerism. So the answer is option D, coordination isomerism. Now let's see what this coordination isomerism actually means. So in coordination isomerism, both the positive and negative ions of the salt are complex ions, and two isomers differ in the distribution of ligands between the cation and anion. For example, in the first case here, this would be the cation and this would be the anion. The second case, it is reversed. Like this is a complex of two. So in the ligands will be exchanged between the portions, the cationic portion as well as the anionic portion. That is the total, that type of isomerism is called the coordination isomerism. And linkage isomerism occurs whenever you have a ligand which has more than one binding site, like SCN. So or CNO. In such cases, it can bind to, the ligand can bind through carbon. If in case of CNO, it can bind through, or SCN. Let's take it for SCN. So it can bind through carbon as well as the sulfur. So in such cases, we can have the linkage isomerism, from which part it binds. According to that, the isomers will be different. The product formed when 1-butane is heated with HgSO4 and H2SO4 is. So basically this is a hydration reaction. So first of all, the triple bond in the triple bond, OH will be added, and it will be added to the carbon atom with least number of hydrogen. So here OH will be formed. But you can see that here tautomerism will occur, which is called the keto-enol tautomerism, because enol form is less stable compared to the keto form. So ketone will be formed from the enol. First of all, what happens? You will get an enol. From the name itself, an enol will be having a double bond as well as an ol, or hydroxy group or OH group will be there. So in enol will be converted to keto form because keto form is more stable than the enol form. So basically HSO4 and H2SO4 will be forming the hydration or will be giving the hydroxyl group and forming an enol which will undergo keto-enol tautomerism to form the ketone. So here the answer would be here out of the all the answers. 1 butane, the answer would be 2 butanol because it is in the second position, 1, 2. So the answer would be option D, 2 butanol. Hope it is clear to you. The next question, the electrophile that attack the aromatic system in Riemann-Tiemann reaction is. So I have already done so many aromatic reactions, I mean the organic reactions. I'll give the link in description box below. Go watch all the videos because it will be really helping you in the longer run. Even in MSc, you have a whole lot of name reactions to study. I have covered the shortcuts of many of those name reactions, which is important in MSc chemistry. So go watch that. It's important for your entrances as well as the coming years. That is your 2 years of MSc. So let's see here. The answer is dichlorocarbon, which is option C. Carbene will be the electrophile, and it will be attacking the ortho position of phenol. Now let's take a look at the representative reaction here. So what happens? Phenol in the presence of CHCl3, which is chloroform, and a base, strong base, to form salicylaldehyde. So in the ortho position, you will get a CHO group. That is the reaction. In Riemann-Tiemann reaction, the phenol will be getting converted to salicylaldehyde. So this OH group will be attacking the CHCl3 to form CCl2 carbene. That is dichlorocarbene. And from there, the further reactions will be taking place. So the answer is option option C, CCl2, which is the dichlorocarbene. Next question, dash is a purine base present in RNA. So whenever you hear RNA, the first answer that comes to your mind is uracil. But here there is a catch. Here the question what asked is purine base. So purine and pyrimidine are two different types of complexes. In pyrimidine, there will be a single ring, which is the main structure, and the ones which has similarities to the pyrimidine or the pyrimidine derivatives are the thymine, cytosine, and uracil, whereas purine derivative, which is having two cycles, two rings, it is the purine derivatives are guanine and adenine. So here the answer is option D, guanine, because only one of the given options is a purine base. Uracil is a base present in uracil, but it is not the purine base, but it is pyrimidine base. Also, cytosine is also a pyrimidine base. You are asked a purine base, so the answer would be either adenine or guanine. Then histamine is an amino acid, not something present in nucleic acid. It will be present in a protein. Now further, I have some more things to say here. Thymine, cytosine, adenine, and guanine will be present in DNA. So instead of in case of RNA, thymine will not be present. The rest of the four will be present in case of RNA. So instead of thymine in RNA, you will be having uracil. That is the difference you have in DNA as well as RNA. And also the sugar differs. I have made a video already on the biomolecules part covering the nucleic acid. You can watch that for more reference. So that will be very much helpful for you. In that same video, I have covered so many other biomolecules. It is going to be helpful for you. Watch that. Next question, mole fraction of the solute in a 1 molar aqueous solution is. So here, first of all, you need to know the definition of molar aqueous solution. So it is not molar. Molar means 1 mole in 1 liter of the solution. But since it is molar, AL, it means that 1 mole of solute is present in 1 kilogram or 1000 gram of water. So it is 1 kilogram, the number of moles in 1 kilogram of water per kg of water, or the solvent is called the molar solution. Since it is aqueous solution, here you have the weight of water. Now the molecular weight of water is 18 gram per mole. First of all, we will find the number of moles of water. So the total number of moles will be given mass by molar mass, which will be W by M, which is equal to 1000 by 18 or 55.56. Further, we have mole fraction of a solute. So if you have two components 1 comma 2, the mole fraction of the first one x1 or the chi, it is actually chi 1 is equal to n1 by n1 plus n2, where n1 is the number of moles of the solute divided by the total number of moles. And if the mole fraction of solvent is asked, then instead of n1 you will have n2 divided by n1 plus n2. So which component is asked in the numerator, the number of moles of that component should be considered, and the total number of moles should be considered in the denominator. Now let's solve this. So the number of moles of solute is given as, since it is 1 molar solution, the number of moles of solute is 1. So 1 divided by 1 plus 55.56, which is approximately equal to 0.018. So here the closest value is 0.0177. So option C would be our answer. What are the steps we have followed here? In 1 molar solution, we find the mass of water, number of moles of water, and further the mole fraction equation. In 3 steps, you will get this answer. Next question, which of the following has minimum bond length? So the first point is lesser the bond order, longer the bond length. So if the lesser the bond order means, if the bond order is 1, it means that there is no strong bond between, like H2. It is a bond order 1. So the bond between these two is not very strong, and so it can easily be broken. For example, now if you are considering N2, it is a triple bonded compound. So the bond order is high, and therefore these two atoms will be so close to each other because it is a very strong bond, and therefore the bond length will be very much less. So lesser the bond order, longer the bond length. So we have to find the bond order of each of these, and then we have to find the bond length, the minimum or the maximum bond length according to the question. So I have already done a video on shortcuts on bond inorganic chemistry, where I have covered the shortcut to find the bond order. So I have used the same methodology here, and I have found the bond order of each of these. So the bond order of O2 is 2, the bond order of O2 plus is 2.5, bond order of O2 minus is 1.5, and O2 2 minus is 1. So we have these 4 bond orders here, and out of this we can see the bond order of O2 plus is the largest, and therefore this will be having the minimum bond length because it is a very strong bond. So the answer, our answer would be option B, O2 2 plus. This is not the answer, this is not the answer, this is not the answer. O2 plus is the answer. So what you have to do, first of all, you have to find the bond order, and I understand that lesser the bond order, then longer will be the bond length. Now let's also, I'll be giving the link of the inorganic shortcuts in the description box. Watch that. It will be giving you the answers within 1 or 2 minutes for these kinds of questions. You might not have to spend so much time for these questions. Now the next question, let's go to the next question. Be2 plus is isoelectronic with which of the following ions? So I have already in last part also I have said that isoelectronic means they should have equal number of electrons. So Be2 plus, beryllium has 4 electrons. Since it has 2 plus charges, 2 electrons will be removed. So the total number of electrons in Be2 plus is 2. And we know for Na plus it is 10, Mg2 plus it is 10, and H plus, actually hydrogen has only 1 electron. So H plus is the H plus is definitely not the answer. So only answer left for us is Li plus. Lithium has a number of electrons 3. Then 1 positive charge is there. Therefore, we should remove 1 more electron. Therefore, it becomes 2. I hope you people have understood this. So isoelectronic means there should be total number of electrons should be same. That is the isoelectronic. Next, which of the following statements is not correct? So for a spontaneous process, delta G must be negative. This is a correct statement. Then enthalpy, entropy, free energy, etc. are state variables. True. These state variables and path variables are two different things. So path variables means that the quantity under consideration will depend upon the path. And state variables means they depend upon only the initial and the final state and not how the states are achieved. So all these are state variables. So this is also correct. But the C, spontaneous process is reversible in nature. This is incorrect. So our answer would be option C. This is our answer because a spontaneous process is irreversible in nature. So total of all possible kinds of energy of a system is called the internal energy. That's also true. So our answer is spontaneous process is irreversible in nature. So the statement which is not correct is that the spontaneous process is reversible in nature. I hope you have understood this. Now the final question for the day is, caprolactam is used for the manufacture of which of the following? So you have a lot of polymers given here. Let's take a look at the structure of caprolactam. So caprolactam structure is this. So you have a 7-membered ring where one of the member is NH, then you have a double bond O. This is caprolactam, and the answer is nylon 6, option C. Also, let's take a look at the structure of nylon 6. So NH, there will be CH2 5. 1, 2, 3, 4, 5. So NH, we can simplify this and write it as NH CH2 5 times. I'll be writing this CH2 5 times CON. This would be the simplified form of the polymer. So nylon 6 is the answer. I have also done a video on polymers, not one, actually more than one videos on polymer. I'll try to give the link in the description box. You people should watch almost all the videos because we have been making these videos for a long time, and right now we know almost what kinds of question comes for your examination. So I would suggest you to watch all the important lectures that we have made and cover the questions of not just your examination, that is all the MSc entrances cover almost the similar syllabus. So covering more than one video or one the question papers of more than one MSc entrance is going to help you. There is no harm in practicing the questions. It is only going to help you even in future. So do that. And the structures, all these structures I have created using Chemdro. That I just wanted to inform you that as well. These are not copied structures. I have drawn the structures using Chemdro. So that's all for today. Whatever videos I have mentioned in the beginning will be uploaded very soon. Thank you so much for watching. If you're a new person to this channel, please subscribe our channel and hit the bell icon for your notifications. We'll keep making the videos you want, and we all hope that you people score really well and get the course or the job that you deserve. For all the best, and thank you.